We are back with more lockdown science, and today we are doing a response video to a video that's linked in the description below, where the video creator makes or buys a bunch of robotic tiles and has those robotic tiles start to blink, and over time they coordinate, and very quickly they are all blinking in unison. Now, there are a lot of videos like that on YouTube where people would like to get involved, but there's an investment. So in this case, there would be an investment in learning how to make or just financially buying those robotic tiles and then learning how to program them. And that will put a lot of people off from being able to get involved. What I'm going to show you today is how you can explore the same effect with almost no nonsense. The only thing that you would have to do is download and install a piece of software called NetLogo. And when you open it up, it looks something like this. Now yours will look slightly different because I have changed the settings. So the first thing we will do is go and sort that out. You can pause the screen and copy my settings exactly if you want, but the important thing is you need to make sure that the world wraps horizontally and that the origin is in the center. The rest is just changing the size of the black box. Then the only other thing that we need to do is put two buttons on our screen. You can put them anywhere, but select a button and call the first one Setup. And the second one, Go. And the only thing here is make sure that you tick Forever on the Go command. And that's it, that's the interface done. And I give you a sneaky preview of the code. Here is the code, and that's literally all it looks like. So I will take you through this. First thing is that our robots in NetLogo are actually going to be called turtles. So instead of robotic tiles, we are dealing with turtles. And all that I've done here is I've given them each a variable that's going to hold details of who their neighbours are. So turtles own NEIS. The NEIS variable is going to hold their two neighbours. And then when you press setup, these commands get executed. So to setup and end, everything in there happens when you press the setup button. First thing is clear all. Make sure you clear all because that will wipe the memory from the last time the computer was used. And reset ticks will give us a nice counter to tell us how quickly these things are able to coordinate. Then these last three commands are setting up my robotic turtles. That first line, ask patches with pycore equals min pycore sprout 1. What on earth is that doing? Very simple actually. This black square is split up into smaller squares called patches, and all that I'm doing with that one line is asking the bottom row of patches to create one turtle each. The command to do that is sprout 1. So ask the patches with the minimum pycore sprout 1. Then the next line, instead of asking the patches, is asking the turtles to do something. So ask turtles set heading 0. In other words, all start pointing in the same direction and the direction is up. Set heading 0 and then set this NEIS variable to be the turtles on either side of you. So turtles on neighbours 4 means the turtles that are to the left, to the right and above and below you. But since they're all in a straight line, there are no turtles above and below, so that just won't happen. And we will set the NEIS variable to be the turtle on either side. And then that last thing is saying move forward a random amount. So each turtle will jump forward a random amount and we will get this. So they're all pointing in the same direction and they're all randomly scattered. Now, our robotic turtles are not going to actually blink. What they will do is they will march up the screen until they get to the top and then they will teleport down to the bottom. So they will just keep going like that over and over and over again. And every time they pass the midpoint, so imagine a line across the middle of the black area, every time they pass the midpoint, we are going to pretend that that is them blinking. And the blinking will do one thing and one thing only. The blinking will attract the two neighbours. So if the neighbour is ahead of the blinking turtle, essentially it will say, hey, look at that. And by doing that, that will take a brief second. So effectively it'll pause in its march up. On the other hand, if the turtle is below the blinking turtle, it will go, hey, look at that, and it will run ahead. And in English, that's all that's going to happen literally. And how that is interpreted, how that has been converted into computer code, I'll show you in a minute. But if you want to see it working, just slow it down a little bit, press setup, and we'll hit go. And like I say, I'll show you the go code in a minute, and we'll see what happens. Now with this code, there is no guarantee that the robots will actually be able to coordinate perfectly. I think what will happen is sometimes they will organize themselves into clusters and coordinate within the cluster. And if I stop it, I think that's what's happened here. So we've got a big cluster here that has been able to coordinate, a smaller cluster here, and then these guys down here, and then some randoms that are kind of flirting between these clusters. Okay, those guys managed it. And maybe the other guys would have managed it if we'd given them long enough. Okay, this group looks like they've done it. No, they haven't, not quite. The reason that we have to stop the program to see, oh, they have done it, look. The reason we have to stop the program to see if they've done it is because with the computer, each turtle acts in discrete time in order. They don't all act at the same time, which means that the screen flickers. So to see if they've actually been able to coordinate, we have to press the stop button. And if they have been able to coordinate, they are all in a line. So let's have a look at the go code. To go and end, everything in between happens when you press go, and this time it happens repeatedly because we made the go button go forever. And there's almost nothing to it. There's almost nothing to it at all. Ask turtles. So this first bit is having the turtles move, and that says ask the turtles to move forward unless they are at the top of the screen, in which case ask them to teleport to the bottom. Now the way to do this is if else patch ahead equals nobody. In other words, if the patch ahead is blank, is outside of the environment, that means you're at the top, then set your y coordinate to be the minimum y coordinate. So teleport down to the bottom. Otherwise go forward one. So that's the command to march. And then the command to do the attraction is just this bit here. So ask the turtles if you are crossing the midpoint. So if y coordinate equals 0, then ask your two neighbours to do something. So then ask neighbours to do the following. Now if their y coordinate is also 0, do nothing. So it says here, if y coordinate does not equal 0, then do this. And this says if else. So if your y coordinate is above 0, so if you're at the top of the screen, then just move back one square. Set your y coordinate to be y coordinate minus 1. Otherwise, you must be below the 0, in which case set your y coordinate to be your y coordinate plus 1, so jump forward one square. And that's the attraction bit, And all of this here is just closing those square brackets. It's very, very easy to get lost in square brackets in NetLogo. And then that last command is just tick, which increments the counter. And that's it. That is our program, and that is what's making these robots coordinate. So give it a go. You can experiment with changing the color and have them physically blink. You could experiment with different shapes of environment, and you could possibly experiment, well, no possibly about it, you could experiment with having the turtles wander around the environment and blink when they meet a partner. And if you like this video, subscribe down here somewhere, and I will see you on the next one. Enjoy!